For today's lesson, we will be writing linear equations. And our standards for today are 6EE7, and 6EE9. So we're going to write a linear equation to express the relationship between two quantities. So today we will be utilizing two variables. Excuse me. So Jacob is X years old. Jenna is 10 years older than him. If Jenna is Y years old, write an equation that relates their ages. So just like when we were building our expressions, we're going to build our equation here. So Jacob is X years old. So we'll start with our X. Jenna is 10 years older than him. So if Jenna is 10 years older, we're going to take whatever age Jacob is, and we're going to add 10 to that. So if Jenna is Y years old, so if we take Jacob's age and add 10, that's going to be the same as Jenna's age. So X plus 10 is going to equal Y. And that is our equation. And we do have the two variables. And the two variables, each one serves a different purpose. So our first variable of X that we used, that is known as our independent variable. And it's our independent variable because we can make Jacob whatever age we want. We can make him 8, we can make him 80. So we can put in whatever value for X that we want for Jake. Doesn't matter or anything else. So Y is our dependent variable. And Y is our dependent variable because its value is based on whatever value we give X. So essentially, Y depends on X. So we won't know Jenna's age until we know Jacob's age, which makes Y our dependent variable. So here we have a rhombus, has sides of length r centimeters. So usually when we have a geometric figure, one of my suggestions is to sketch that figure. That way we know what we're talking about. So there's our rhombus. And what makes a rhombus is that a rhombus has 4 congruent sides. So if it says a rhombus has sides of length r centimeters, we're going to label those side lengths as r. If the perimeter of the rhombus is p centimeters, we want to express p in terms of r. Well, this phrase right here, p in terms of r, helps us set up our equation. So anytime you see that little phrase, p in terms of r, y in terms of x, b in terms of a, that's going to help you create your equation. When it says p in terms of r, we know that the equation will be p equals. If it was y in terms of x, it'd be y equals. B in terms of a, it's b equals, and so on. Okay. So to find the perimeter, you have to add the side lengths. Well, in this situation, we have a rhombus. We know that all the sides of a rhombus are congruent. So what we're going to do, instead of adding all the side lengths, we're just going to take the side lengths, one side length, and multiply it by 4. So p equals 4 times r. So in this situation, p is our dependent variable, and r is our independent variable, because the perimeter depends on whatever the side lengths are. Excuse me. So in the equation, x, so we're talking about the first equation we wrote, x is the independent variable and y is the dependent, because the value of y depends on the value of x. And writing y as an expression using x is called expressing y in terms of x, which is why in that previous one we do have it equaling y, or we could have rewritten it as y equals. Either way is fine. So we're going to write our linear equation here, and usually you start by, again, building your equation, and it usually starts with the expression like we had in that very first one. So Isaac has H baseball cards. Carlos has 7 more baseball cards than Isaac. So write an expression for the number of baseball cards that Carlos has in terms of H. So if Isaac has H baseball cards, Carlos has 7 more. So we're going to add 7 to that. So there's our expression. And then from there, we can take that and we can write our equation. So if Carlos has K baseball cards, express K in terms of H. So there's our statement there, K in terms of. So we're going to have K equals H plus 7. Or if you have H plus 7 equals K, that works as well. So we're going to state our independent and dependent variables. Well, our independent is H because Isaac can have whatever number of cards we want, and Carlos has to have 7 more than that, so Carlos's number depends on what Isaac has. So K would be our dependent variable in this situation. Ashley took P minutes to jog around the park. Sophia took 12 minutes longer to jog around the park. If Sophia took T minutes to jog around the park, express T in terms of P. So again, we have our statement. So T in terms of P means we're going to have T equals. So Ashley took P minutes to jog around the park. Sophia took 12 minutes longer. So T equals P plus 12. So in this situation, P is our independent variable, and T is our dependent variable. A bouquet of roses costs $30. A bouquet of tulips costs M dollars less. If the cost of one bouquet of tulips is N dollars, express N in terms of M. So again, N in terms of, we start with N equals, and the roses cost $30. Bouquet of tulips costs M dollars less. We're going to take the cost of the roses and take the cost of the tulips off. So M is our independent variable, which makes N our dependent variable. Excuse me. Ryan has 7 boxes of marbles. Each box contains B marbles. If he has C marbles altogether, express C in terms of B. So C equals, you have 7 boxes, B marbles in each. So we're going to multiply those together. And again, on here, if you want to write 7B equals C, or B times 7 equals C, or 7 times B equals C, or C equals 7 times B, anything like that, that's perfectly fine. So B is our independent, C is our dependent. A motel charged Mr. Kim X dollars for a stay. Mr. Kim stayed at the motel for 12 nights. If the rate per night for a room was Y dollars, express Y in terms of X. And really the only reason why I usually start my equations with the dependent variable on the left is because when it says Y in terms of, that just helps me set it up. But again, you can put that at the end if you want. Well, if the motel charged X dollars for a stay and he was there for 12 nights, Y equals X divided by 12. And once again, X is your independent, Y, is your dependent. So our end goal with this lesson is to eventually take those equations and turn them into lines on the coordinate plane, which is why they're called linear equations. And one way in order to create the line is once we have the equation down, we'll create what's called a table of values. But before we can get to the table of values, we do need to write our equation. So the length of a rectangular picture frame is 5 inches longer than its width. Writing an equation to show how its width and length are related. Excuse me. So in this situation, we are not given a statement of one of the variables in terms of the other. So when that happens, you just have to look at the situation and ask yourself essentially, what would I need to know first? So the length of a rectangular picture frame is 5 inches longer than its width. Okay. Or you can say, or you can ask yourself, what is based on the other? Okay. So in this situation, I would actually have to know the width first, since the length is dependent upon the width. So I'd start with the width. Since the length is 5 inches longer, I would have to add 5 inches to the width to get my length. So now that I have my equation, I can create this table of values, which you kind of saw at the bottom of your screen there a little bit ago. Okay. And so what this is I can come up with whatever dimensions I want for my width, because they should fall in this pattern. So if the width is 1, the length is 6, because if I put 1 in for W, 1 plus 5 is 6. If the width is 2, the length is going to be 7, because if I put 2 in for W, 2 plus 5 is 7. If the width is 3, the length is 8, because 3 plus 5 is 8. If it's 4, the length is 9, because 4 plus 5 is 9. And if it's 5, then the length is 10, because 5 plus 5 is 10. When you have your table of values, your independent variable is on top. Your dependent variable is on the bottom. So that can even help you write your equation if you're not sure which one's the independent variable and which one's the dependent variable. If you're given a table that's set up already, the value on top is your independent, the value on bottom is your dependent variable. So each can of paint contains 5 gallons of paint. Writing an equation to show the relationship between the number of cans and the volume of paint. So if you're struggling here to write your equation, again, you can look at your table of values, which we have set up. And we'll notice that the number of cans is actually on top, which makes it our independent variable, which makes V our dependent variable. And so we know it's going to be V equals, and it says each can of paint contains 5 gallons of paint. So we're going to take 5 times C, because for every can we get 5 gallons. And now that we have our equation, we can put these values in for C to figure out our volume. Well, if we have 1 can, we have 5 gallons, because 1 times 5 is 5. If we have 2 cans, we have 10, because 2 times 5 is 10. If we have 3, we have 15. 4 is 20, and 5 is 25, because we had to multiply all of those by 5. Excuse me. So the width of a rectangular tank is 2 meters less than its length. If the length is P meters and the width is Q meters, write an equation to express Q in terms of P. So I know I'm going to start with Q equals. So the width of is 2 meters less than the length. Well, if the length is P, we would subtract 2. And so to fill in the missing values, we'll see that if P is 3, Q is 1. So if P is 4, Q is 2, because we got to subtract 2 from it. If P is 5, Q is 3. We see that 6. If P is 6, Q is 4, 7, 5, 8, and 6, because we need to subtract 2. And that is all for today's lesson. I hope this helps.